Hi, welcome to hackaweek.com. This week I have got a hack. I got a crazy hack. I saw a Ben Heck hack about 2 weeks ago, maybe 3, where he had the automatic sunglasses, you know, with the little things that flipped up and down. It had a servo on them and a microcontroller and a battery pack and a whole bunch of stuff. It was a really busy hack and it was a lot of fun. He had a ball with that. But you know what? That inspired me and I really got thinking, like I always do, about how I could make something simpler than what he did and maybe no mechanical device, like something that would tint by itself. And I started thinking maybe LCDs would work, and then I did a little research and found these guys, active shutter LCD glasses for 3D TV watching. They have a little IR sensor right here in the middle, and when it gets a pulse at about 120 hertz, it flips these on and off really fast in sync with the 3D image on the screen. There's like, you know, 2 different angles, and anyway, go read about that if you want to find out more. But I found out that I could probably hack into these and maybe make them go dark with a photoelectric cell and some circuitry, and that would be really cool. And not only that, I think they make me look like Spaceman Spiff. Don't you think so? Anyway, let's get cracking and hacking on these glasses and see if we can turn them into some automatic sunglasses. JFET, are you ready? JFET is ready to help. Look at him. He is so eager to grab tools and get to work. This is the box that these things came in. I found these on eBay pretty cheap, like 13 bucks for these guys. So the first thing we need to do is take these things apart and see what's going on. These have basically on this side some on-off switches, and there's a little USB port there for charging the batteries, which reside over in this side. And there's the glasses, and it looks like there's a nose bridge right here that will come off, and then there's a little screw in there we need to take apart, and we can get inside these things. These little covers probably look to me like they pop off. So anyway, we're gonna jump into time-lapse mode to save you the boredom of watching all this tedious stuff of me taking them apart. We'll just like jump right to it. So here we go. I think these have multiple LCDs on one panel because I can make one go dark by applying voltage to it. And I can do that to the other one as well. So maybe I can just tap right into these, apply a voltage, and hook up the photoelectric cell, and we'll have some automatic sunglasses. So let me see if I can solder up some wires to these guys, disconnect it from the rest of the circuitry, and see what kind of results we get. Okay, I think for starters I'll just try desoldering this connection right here from the LCD. Let's see what happens. See if it'll still work without it connected to any of the circuitry, because there is a little bit of circuitry in here, and I believe there's a battery in this side, if they're anything like the other lenses I had. Okay, let's see what we get here on this one now. I've got 6 volts running through this right now. Ooh, it went dark, and it stayed dark. And it took a while to come back. So that means the circuitry has something going on, a capacitor, I suppose, that takes the charge that I put into the LCD and drains it back off. Okay, I managed to slide that off from the pin that holds that together. Now maybe we can pop this open somehow. There we go. And there's the battery. Cool. Let's get to the other side now. Okay. Well, that's off. Got this lens all flopping around here. And let's pry this one off to be gentle because there's a circuit there. There it is. All the goodies in that side. All the controlling circuits there, and the charging port, USB port. Okay, I've got my USB cable plugged into a wall wart, one of those USB style wall wart charger thingies, and I will plug this into the glasses now. Get this battery charging. Oh look, there's a little red blinky light, which means it's charging, I guess. I suppose I could RTFM here and find out a little more about that. Oh look, it's in Japanese. Anyone want to translate that for me? Ah, wait, I know. Just flip it over and we have English, although it's written the other way. No, there we go. Okay. Yes, indeed, right there it says that the little blinking red light is the charging indicator. Okay, so let's let that sit and charge for a while, and then we'll come back later and play some more. This is exciting. Well, I've come to the conclusion that that little battery is just not enough to do both of these. I can do one at a time, like that. So I think I'm going to bypass all this circuitry, solder up some wires on each one of the LCDs here, and then figure out a way to discharge them after they're charged and dark with a capacitor, maybe. Yeah. Okay, I've been playing around with capacitors here on this thing, and I'm using a 0.01 microfarad electrolytic capacitor, and I have it bridging the two leads that run the LCD. Now here's a funny thing. If I connect my power to the negative side, positive side to the negative side of the capacitor, and then I connect the negative power supply to the positive side of the capacitor, you see the LCD goes dark, and when I take it away, it goes clear really quickly. Just like that. But if I hook it up the other way around, and I put the positive on the positive side of the capacitor, and I hook the negative to the negative side of the capacitor, it also goes dark, but it takes a long time for it to discharge. Interesting. If someone can explain that one to me, I'd be willing to learn why that's happening with a capacitor. I guess maybe what's happening there is that this is holding a voltage and the capacitor is discharging it. And because I am hooking it up backwards, I'm charging this with a voltage but not the capacitor. I'm leaving the capacitor empty, as it were. And as soon as I take away that voltage, any residual charge left in here drains into the capacitor. That's my theory. If there's any EEs out there that might be able to confirm that, please let me know. Well, let's move along now and see if we can get a photoelectric cell in this circuit to make it react with light. Here's a photoelectric cell. Now let's try attaching that. Okay, the LED goes dark. What if I block the photoelectric cell? No effect. Well, I may have to make a simple light activated switch with this photoelectric cell and a transistor so that when the light is blocked it turns off the switch, essentially. What we need for this circuit is a light detector, and we can build that with a photocell and a NPN transistor. And the photocell will turn the transistor on, and then that will in turn turn on the power to the LCD lens. that came out of the glasses, this thing here. So let's draw that circuit. It's really pretty simple. Let's draw a positive rail here, and we'll put a negative rail here. And we'll go ahead and take that up here to our transistor. This will be the transistor here. This is an NPN transistor, so at the emitter we draw the arrow going away from the transistor. So that's the emitter. This will be the collector. This is the base. Now the photocell will go right here, also known as a light dependent resistor, LDR. So that goes between the positive rail and the base, and then between the base and ground is another resistor, and that resistor will be somewhere between 1K and 4.7K. So I may put a little trim pot in there. This is the negative side, by the way. 6 volts over here. And the load, the LCD lens, that would go right here. This would be the negative side, and this would be the positive side of it. So when light strikes this, it allows some voltage to go through here because the resistance goes down when the light strikes the LDR and turns this resistor on. And then that allows current to flow from here through the load, through the transistor to ground. So the load will be the LCD lens. For test purposes, I'm going to put a little LED on my breadboard to test this out. But there's the basic circuit of a light detector using a photocell and a transistor. This is that circuit all breadboarded up now, and I've got it running on 6 volts. Right there is the photoelectric cell, or the light dependent resistor, whatever you want to call it. And when I block it from light, the voltage doesn't get to the LED and it goes out. There it is. And as it turns out, that one resistor I was talking about, the 1K to 4.7K, turns out a 470 ohm works well with this particular LDR. The thing with these photocells is they vary quite a bit from photocell to photocell. Even if they look the same and they came from the same batch, they can still vary in the way that they react a bit. So don't be surprised if you try this and you get a little different result. Just play with this resistor till you get the result you want. And now we need to hook this up to the LCD lens and see if we can control that. This is the final breadboarded circuit with 2 batteries running it for a total of about 8 volts for a power source, and then I put a LM317 here to regulate the voltage down to around 5.5 volts. That seems to be around the proper voltage for these things to function. Any darker than that, and I noticed some strange lines starting to show up in the LCD. I didn't like that. So there it all is with the photoelectric cell, and you can see that it goes dark and light with the change in the light striking the photoelectric cell. This works pretty well for an ambient room light. It doesn't really trigger it. As soon as you get out in the sunlight, it does. So now it's time to get it into here with the photoelectric cell. All of that circuitry needs to get crammed into this bow here, and the 2 batteries over in this side. Okay, here we go. Time to hook up some batteries. Let's see what we got. Hey, look at that. The lenses went dark. And they go light. And they go dark. As you can see. Yippee! Alright, there it is. It's all in there. Whew! Pretty tight fit. Let's see if we can get up close and personal and take a look at this. Wow, look at that. It's all crammed in there. And there should be room for the cover. We'll get the wires and everything all routed to the other side. Batteries mounted, LCDs. Get it outside, see how it works. That last bit was the addition of an on-off switch. A little tiny itty bitty on-off switch. We have to have an on-off switch. Okay, back to the rest of the build. There we go. They are assembled. Let's throw the on switch and see what happens. They work! Alright, let's put them on and take them outside. Okay, I'm here inside the house and I know they kind of look tinted right now, but if I get in really close maybe you'll see they're still somewhat clear. They have a little bit of a tint to them anyway, but as I walk outdoors into bright light, they go really dark. So that they work. They work! I'm looking outdoors. Now I'm looking into the house, and as I turn around and get in the bright light, they go dark. How cool is that? Now, you know, I'll remind you right now, these are really not intended for sunglasses. I have no idea what kind of UV or IR or UVA, UVB, anything that these things block. So if you build these things, be aware that you do this at your own risk. I have no idea if these really act as sunglasses or not, and they are made of glass and it's very thin, and if you were to get something striking you right here, they could break and really, really hurt your eyeball. So if you do this hack, it's at your own risk and you are responsible for anything that might happen. It's just a fun hack to do though, because it's kind of like you've got your own automatic sunglasses, sort of like a welder glass, right? You know, as you get in the bright light, blink, there it goes. Let me show you what it looks like from my side. This is looking in the house at the kitty cats through the lenses, and as I turn and go outside, you see they go dark. They go dark. It's really cool. And of course my camera adjusts for that, but let's look at that one more time. Looking inside, as we go outside, they go dark. Inside, outside. Very cool. So there it is, the automatic LCD sunglasses made from a pair of active shutter 3D glasses. I guess the Navy is working on something like this. I saw an article recently published on phys.org.com about that. They adjust to the ambient light accordingly, I guess, and probably use this similar technology. And I think it does it through polarization of these lenses. I think there's 2 layers to them, and when the LCDs activate, it actually causes the polarization to be at 90 degrees to each other, and then it goes dark. That's my theory anyway. If anybody knows different, hey, post it in the comments below. Let's have a discussion about it. And until next time, keep on hacking. I think these make me look like Spaceman Spiff from Calvin and Hobbes.